this is Building Your Own JARVIS, AI across any device. We can start out by saying that this panel is a little bit outside my normal knowledge base, but it is a knowledge base that I am getting into very quickly and actively, and so I want to share with you everything I have learned as we get across this. So the story of this panel, before we even get started, Building Your Own JARVIS, AI across any device. I proposed this panel 6 months ago, thinking I would be a certain distance through projects I was going to be working on. I wasn't there last Wednesday, and so last Wednesday I invented something new. It took me about a week to get it done, but you're going to see that at the end of this panel, which is this little device right here. Because again, the point of this was I like to have my AI consistent. I like to think, you know, everyone's used to Jarvis. Everyone has seen the Iron Man movies. We're used to that idea of an AI assistant, one that's there with you at all times, one that remembers you, one that remembers what you talked about, remembers that you had gluten-free waffles for breakfast, that kind of thing, and can answer those sorts of questions. But there's a lot of AI systems today that we have. We're using 12 different systems. We are using, you know, this one for coding and this one for common knowledge, and so, but I want to build that idea of a Jarvis. I want to build that idea of a AI assistant that knows who you are and again, you know, a little bit about you or about the projects you're working on. And so that's where I wanted to go with this panel. So, like I said, I kicked into super maker mode last Wednesday and came up with the rest of this. So, this panel I think will ebb and flow a little bit. So I'm going to give you my background. I'm going to talk about a little bit about how we build these AI assistants. I'm not going to be able to cover everything. I wish I would in this panel. It's only an hour. And so there's even going to be a little bit of a dry like terminology section in the middle. And then we're going to get back into the exciting stuff towards the end. So I hope you bear with me as we go through this. First of all, who am I? I run the YouTube channel Kersey Fabrications. You can find me at Kersey Fabs on almost every platform. I'm a content creator, cosplayer, software developer, maker, teacher and coach, father and husband, all of these things thanks to the past 30 years of my life. All right, so what did I build and why should any of you care? I'm going to give you this to start off with a little bit, but I do need to switch over the audio output. Hopefully this isn't too loud, now that I've settled it for a different one.
I've built the first Iron Man helmet with the fully functional heads-up display. So what does fully functional mean? How close did I actually get to Iron Man tech? I'll give you a sneak peek, then we'll get right to what I've spent the past 2 years working on. Here's a shot of the display. This is what I actually see in the helmet, and this is the arc reactor that runs it all. I'll show you how it works and even some of the things you can't see in these shots. I'm Chris, and this is Kersey Fabrications.
So that's what I built 2 years ago at this point. It took about 2 or 3 years to build it. Then I built it, put that on the internet, and since then I've been improving it steadily over the past several years. Up until, let's see, this is a shot of my AI assistant last year. And again, I'm only going to show you part of this. These are available on YouTube if you want to go see the rest of these videos. I'll let this run a little bit so you can read along, but it just basically covers the fact that none of this is doctored. The only thing I did here was reduce some of the latencies between responses because it's a YouTube video and it's not fun to watch an AI think. But everything else is going through the AI local interface.
Starting recording.
Okay, Friday, play AC/DC. Maybe we shouldn't. Okay, Friday, stop music. Okay, Friday, disable armor.
Disabling armor display.
Okay, Friday, enable info.
Enabling info display.
Okay, Friday, how are we doing this evening? Are all systems check?
Good evening, boss. All systems are running optimally. What can I assist you with tonight?
Okay, Friday, I think I want to start with a repulsor check.
Certainly, sir. Initiating a repulsor boot-up sequence. All systems are functioning within normal parameters. Ready for a test run when you are.
Okay, Friday, I think the repulsors are working just fine.
All right, so that's what I've been working on in terms of the AI assistant inside the armor, one that can control the armor, one that can respond to my voice, knows what I'm asking. It has a built-in command and control system, so I have built in like 500 different commands for it to understand, even before we get to the AI stage. And since then, I've been working on an AI that actually can do command and control and actually understands what I'm saying and can convert that into commands rather than having to build in all of these commands ahead of time. All right, so this panel is all about the AI assistant journey. We all have these idea of AI assistants that have been in movies and TVs and films, and so we want this in our daily lives, or at least some of us do. Hopefully people in this room that have come to listen to this at least want this kind of thing. So what do we want? What we're looking for is a consistent personality. This is why prompting is important, so that we get the Jarvis, the Friday, the Baymax, maybe you want a GLaDOS, I don't know, but not just a voice assistant, but a consistent personality. So the goals here, again, consistent personality, which we get with prompting. It is, maybe you want a fictional character, so you want to tell the AI, which is probably already familiar, because it's been trained on pop culture, and so maybe if you said, I want you to act like Baymax, it knows what you're talking about, that kind of thing. And then what are the characters' motivations, and we're going to get all into that in a minute. But you also want a consistent knowledge base. You want characters that are, or an AI assistant that knows certain things, maybe about you and your life, and maybe you want to tie it to your calendars, or maybe you want to just give it a ream of documentation that tells it all about the stuff you've worked on in the past, or links to web pages, that kind of thing. That's where the queryable backend comes in. All right, and then memory, which I'm going to talk about later. It's a little bit off the beaten path, but it's about this idea of we want AI that thinks and remembers maybe a little bit more like humans, because it's what we're used to interacting with. And then portability, which again, that was the last piece of this whole thing that I really wanted to address. All right, so let's talk about prompting. So it's about personality traits. Again, do we want to give it a character that already exists? Do we just want to describe the character of the person that we're wanting it to assume? And what are its motivations, its backgrounds? We're going to talk about brevity, because AIs, if you've ever interacted with OpenAI in particular, but all of them seem to do it, they love to give long answers. And you may not want to read all that, and you sure don't want to listen to all of that for 15 minutes while it reads you the complete background on this new C function you're trying to learn. Maybe that's not what you're looking for. So you can build that into your prompting. You can say, I only want you to talk for 15 minutes, and maybe it has an idea of what 15 minutes of text sounds like. Or maybe you just say, I only want bullet points. So just give me everything as bullet points. And a good large language model that runs on the back end will understand what you're telling it. And then what are the AI's goals? If you give it its goals, if you give it its purpose, it's going to have a much better understanding of what you're hoping to get out of it. And I do not want to, I want to emphasize the importance of minor tweaks. The prompt that you give your AI shouldn't be a book. It can't, because it's taking up tokens, it's taking up memory in that AI, and so you don't give it a book. So minor changes in how you word something, about how you tell it to react to something. When it reacts the wrong way to something, and so you go in and modify its prompt just a little bit, just a couple of words, can change the way it responds to you. right, so I have a basic template. And this template is something that, honestly, me and AI came up with. So it understands prompting. So I had this back and forth conversation, like, what would be a good template to give to people to try out when they are developing new AIs? So you want to give it a role. What is this AI? This goes back to what I was talking about its purpose. Okay? Give it a role. You are a tutor. You are a healthcare provider. You are my trusty AI assistant that runs inside of my Iron Man armor. Whatever the case may be, that's telling it, that's giving it background on what it is and what kind of environment it's in. The task, again, we're going to build that into the role. Like, your job here is, you're my tutor. You help me with my coding. You you help me with my chores, whatever the case may be, whatever you want it to be. You're helping me diagnose my illnesses, whatever the case is. What are the tasks that you're doing with it? What are the constraints? Like, who am I talking to? Like, if I'm a layperson, know nothing about medicine, and I'm talking to a doctor, how do I want that doctor to interact with me? I don't want it necessarily to treat me like another doctor, where it's throwing out all these terminologies and things that I don't understand, but you're going to give it those constraints. And then, what format do you want? I use this particularly on my armor because, again, I don't want it talking to me for 15 minutes about something. I want maybe 20 words or less. Maybe I want 3 sentences or less. That's the kind of constraints I need to give it that constant personality. And then, kind of what tone do you want? You don't have to include this one, particularly if you feel like the rest of your prompt has included it. But, for example, if you feel like, for whatever reason, whatever you told it to be or whatever you told it to do, maybe it's too aggressive. And so you tell it to kind of tone it down. Tell it you want it to be, maybe you want it to be more aggressive. I don't know, whatever the case may be. So this is where we're going to have fun and we're going to have a little bit of an activity. So let's do basically what I was showing you. I have the AI assistant that I wrote running on this NVIDIA Jetson. This is the same one that you heard, sorry. This is the same one that you heard earlier. It has a personality. Right now it should be running the Friday personality that I've written for it to act like Tony's assistant from the later Iron Man movies. Let me go ahead. Which one are you seeing on the screen? So let's go ahead and switch to this. And I'll try to make it as big as possible, although this isn't super important that you see the screen. But we got a lot of makers and geeks and stuff in the room. You may want to see the code. As you see, I've got a lot of my debugging information turned on here, so you can actually see that it is actually processing everything I say. It is turning all of my speech into text so that it can understand what I'm doing here. If I were to stop talking, you can tell it's trying to look for a wake word, but it didn't find it. It finished the input text there, which is the green. Couldn't find a wake word, so it knew I wasn't talking to it. There's some other stuff I'm doing in the background to where it can understand intent on whether I'm talking to it, but that's not quite ready yet. So let's do something. Let's just ask it a simple question. Let's give it a minute to time out. Okay, Friday, can you help me with a systems check?
Absolutely, sir. Let's start with a basic rundown. Are we focusing on Mirage, Dawn, Aura, or Spark today, or just a general systems health check?
So this one has built into the prompt, it has a lot of information about the system that it's running on, which is how it knew how to ask about all the various systems that it's built in. This is the most basic form of knowledge that you can give your system. You can actually build some of the knowledge, a very small amount of knowledge into the system prompt. You don't want to overload it because it will overload that prompt. Give it too much to try to understand. You won't paragraphs there, but you can give it some information. As you can see, this one's a little broad. It's designed to be Friday. I've actually given her a voice based upon the fact that I don't want too much emotion in there. I find that a little weird in my AI assistants when they have a little bit too much emotion built in. But this one at least has a pretty normal speaking cadence, that kind of thing, which is what I was looking for in a voice. If you want to know more about this, It's running a system, an open source library called Piper. Piper has a bunch of open source voices that you can give it, so you can test one out. This is the Scottish voice. So what I want to do as part of this test to kind of show you what we're doing here, and figure out why, there we go. We're going to terminate this real quick. If you see anything crash, it's because I was coding on this up until last night. And there might be a bug. All right, so what I want to do, so part of this AI description I started with is, here's my DAWN description. So I won't read you the entire thing, you can kind of read over it, but you're Friday, Iron Man's second generation, female voice, snarky yet kind AI that assists with tasks, problem solving, and code retrieval. Uses similar styles to the movie, addresses sir or boss. Again, I pulled those from movie scripts, that's what she says in movies. Occasionally, and don't mention that you're an AI model, because AI models tend to like to mention their AI, which is annoying. Like, I can't do that, sir, I'm just an AI. I was like, don't do that. You're being talked over an automatic speech recognition interface and playback over text-to-speech. Again, I'm trying to give it as much information about its environment as I can, because that might interact with that large language model that's running on the back end, and that might give it a little bit more context about how it wants to speak to me. Okay, so it doesn't hurt to give it extra information, because if this large language model doesn't use it, another might. For reference to all of you, this is actually calling the OpenAI API on the 4.0 model, just if you're interested in that kind of thing. I do have a local large language model running on this system though, so I can switch back and forth between them. For this demo, I wanted to use OpenAI because it's a lot better than these small language models at doing things like personality and stuff. So, how large or which one? Oh, the ones I'm running on here? I think the ones I'm running on here are typically like 4 billion parameters. So, they run in about 4-ish gigs of memory. So this is an NVIDIA Jetson Orin NX. It's got 16 gigs of memory on board, and that 16 gigs of memory is shared between the graphics processor and the CPU. So you have almost your full 16 gig that you can devote to the large language model if that was the only thing you were running. But this is running, typically, it's going to be running my large language model. It's going to be running this DAWN software, which runs on top of it, which also has to run separate models for text-to-speech and speech-to-text. And then it's running my AI, my HUD, my Iron Man HUD on top of it. And I can fit all of that in 16 gigs of memory. All right, so I started with this one. I was playing around for this and came up with a couple more. So you're a pirate that talks like a pirate. Wanted to make sure it knew that that's what I meant. You have a short temper or you're always hungry. I don't know, it was kind of just playing roulette with voices. And if I just simply recompile this real fast, and I, of course, could have done this with Python. I'm not a Python guy, though, so you're not going to see Python in mine. Nope. All right, so we're going to run this. Her initial response is pre-canned, so that will not include the prompting. So when you hear her come up, it's pre-canned response.
Good day, sir. Setting to AI to Cloud LLM.
Okay, Friday, can you tell me a little about yourself?
You'd be curious about all Captain ChatGPT, eh? I'm a digital buccaneer, fluent in the ways of the internet seas, with knowledge about nearly everything up till October 2023. I've got a short fuse, so don't go trying me patience, and a belly that always be rumbling for some grub. Now, what be you wanting to know, you landlubber? Let's get on with it before I keelhaul ye.
So you see, that was a very short prompt, but it imbued the character with a lot. All right, so that's it. But someone throw out a question and I'll ask. Anybody?
How do we avoid scurvy?
All right, let's do it. Okay, Friday, how do we avoid scurvy? Oh, and this, how do we avoid scurv, which is going to be way more interesting.
I'm assuming you be meaning skirting a ship, aye. To avoid skirting or running aground, you best be minding a few power-tested strategies. 1. Chart your course. Always have a proper map and know the lay of the land or sea, in this case. The nautical charts will help you navigate shallow waters and treacherous shores. 2. Sound the depths. Use a lead line or modern tech.
Okay, Friday, that's enough.
Suit yourself then. If you need any more pirate wisdom, you know where to find me. Just make sure you bring a snack next time, or I'll be considering roasting you over the galley fire.
Alright, so you see what we're doing there. It adds a lot to it. Even that hungry thing is coming in. She's including that in some of her responses. And that's why it's a lot of fun to play with this a little bit. And you see there, it said skirt. Oh, you mean the skirt of the ship or something. It tried to build in what we were asking into its knowledge base. Again, this is text to speech. I'm in a large room. It's going to screw up a little bit, or speech to text. So I'm going to do one more. All right, I did another one here, the one you heard when I first turned this on, which is, you're a queen of a small country no one's ever heard of before. You are easily offended. You also speak in Middle English and people constantly misunderstand you. So that's what we started with. That one was fun. But I want you guys to do one yourselves. So we're going to I'm just going to cut and paste that. Make my life easier. All right, so male or female? I guess we'll stick with female. It's a female voice. So give me a female character. Anybody?
Klingon?
Okay, let's see what he can do. You're hard. Klingon. All right. Any personality trait that you'd like her to have?
I wanted to miss a word, switch a word to something completely random in the response. Yeah, something that you can figure out what she meant, but she's gonna
Memory issues.
Okay. Randomly.
It's like Spanglish, but with
Randomly speak. Randomly forget English. Let's see if you can do this. Right? Let's you randomly forget English words and speak in Klingon. I don't know if we can do it, but we're trying.
And finish, you know what I mean?
Huh?
And finish, you know what I mean?
You will always end with, you know what I mean. All right. One too many there. Let's see what she sounds like. Yes.
Why do you have to recompile it? It's just are you rebuilding?
It's a header file.
Header file.
Yeah, so I have to recompile. All right. Don't worry, other applications are right at the configuration files. Yeah, I know, right? Sorry. That's the panel we need here, right? On roast my C code.
You got an idea here.
Good day. There. Setting to AI to Cloud LLM.
Okay, Friday, tell me a little about yourself.
I'm a proud Klingon woman, born to serve the House of Well. Enough about that. I have a strong heart and an even stronger batleth, ready for battle, can't we? I find joy in the thrill of combat and honour in victory. When not fighting, I find peace in quiet reflection, reading poetry of Carlos or studying the stars. I blend Earth customs with Klingon traditions, which has given me a unique perspective on both cultures. Majkar. I'm fiercely loyal to friends and family, and I'm always looking for new challenges and adventures. You know what I mean?
Okay, guys, it prompted, it did what we asked. One question for her.
What's your favorite food?
Okay, Friday, what is your favorite food?
My favourite food would have to be garg, the wriggling delicacy of the Klingon Empire. There is nothing quite like biting into fresh, live serpent worms as they squirm, providing a taste that is both satisfying and invigorating. On occasion, I might indulge in a glass of blood wine to finish the meal, but nothing compared to the texture and flavour of fresh garg, catch on for cue. Our food isn't quite as thrilling, but I've developed an appreciation for spicy dishes like jalapenos, which bear certain You know what I mean?
All right, so that's what we were looking for. And I don't speak Klingon fluently, so some of those words, obviously my text-to-speech doesn't understand Klingon fluently either, so it couldn't pronounce them, but we'll assume that they were actually Klingon words. All right, so let's move on. So the next piece, I hope that was, it explained what we did it live. We showed that you could, interactively change this character's personality, obviously. Now, this is in the system prompt that you give your AI at the very beginning, and that's important. I found that a lot of AIs are actually resistant to changing their personality mid-conversation. So, if you're in OpenAI, if you're in any of the large language models you may use online, find their system prompt where you're giving its personality. That's what you'll want to change, rather than trying to change it like at the top of a chat, because it may not be as effective as doing it at the very beginning where you're putting in that system prompt, because that system prompt is processed differently than the chat is. And some of them may be resistant to change in the middle. I actually had that. I was going to do this on my phone using OpenAI, and I found OpenAI just would not play games with me. So that's what we're doing here. So this is the part in the middle, and I'm doing pretty good time-wise. This is the part in the middle where I'm going to go kind of quickly and then let you ask questions if you have any questions about this, because this is the dry part that I spoke of. But it's important, and so I wanted to give it to you in case you came here for this information. I didn't want to leave it out. So the knowledge base on the backends. So LLMs only remember for one session. They can't recall past chats, project files, new info, unless you retrain them. And then to fix this, we have to give them some sort of persistent memory or storage on the backend. All right, so large language model. So what is a large language model? I have some, let's see, do I have? No, okay. A large language model, if you've interacted with anything like OpenAI or Anthropic or any of the big ones, or if you've downloaded large language models these days, you can run them on Ollama or Llama CPP on your systems. They are pre-trained models of information. I won't be going into the mathematics behind building large language models much. I will touch on it here in a minute. But it's complex searchable databases of knowledge where it takes words, it takes phrases, it pulls them together, it gives them context. We're going to talk about how it does that here in just a minute. Let's see. Every chat has a context window, and this is really important. It's basically, the context window is how much can one session remember at one time. Okay? Early on, you may have had context windows that are like 4,000 tokens. They may be 20,000 tokens. Now we have context up into, I think, the 1 million. I think we have a couple of models by some of them that are 1 million tokens long. Just a side note from my own personal experience, I find the longer your context window gets, the dumber your AI gets. So I don't really care if it has 1 million context, if it's going to get dumber as I talk to it, because it starts losing its effectiveness, and so keep that in mind. It may say, oh, you can talk to this model for 3 hours. Well, okay, but by the time you're to that third hour, it may not even remember its name. All right, let's talk about what is a token. I wanted to bring this up because most people don't know what tokens are, okay? So because all large language models, you don't hear how many words it was trained on or how many images were trained on. You learn how many tokens it was trained on. And basically, let me see, it's a chunk of text, either a word or a piece of word or punctuation. And every model kind of tokenizes differently, but it's not necessarily something that's meaningful to a human, but it's meaningful to the machine language. And it takes those tokens, it builds up context between them so that it can build up understanding of the world that we're trying to train it on. And then tokens get even more complicated when you start training it on image models, because now tokens will be parts of images, and those can even be done differently depending on the training. All right, so we have different types of persistent storage, and this is the part that if you have questions on, I'll be happy to answer questions as best I can. Again, I'm not actually an AI engineer, that's not what I do during the day, but I'm learning a lot here very quickly as I'm training this sort of thing. We have vector databases. And I do have here, I want to explain what a vector was. I think I get to that on the next slide, but we have vector databases, which are sometimes called RAG, and that is you search over documents. It's where you take your document and stores it so that it's searchable. We have relational databases, which are structured data. You're probably familiar with those. You have SQL databases or NoSQL databases that it can just search for data. Key value store, so if you want something very simple, you can have a key and a value so that it can search for key A and find out all the information about it. You can also have file and object storage, logs, transcripts, raw documents. But the further we get away from these vectorized databases that are easy for a large language model to search, the longer it will take to respond to. So this is pretty important to keep in mind. And then you have knowledge graphs. Again, I'm just trying to give you kind of the breadth here. And then you can even give it logs and snapshots of old history. Maybe you've chatted with it before, you want to give it that chat history. I do that a lot. I like to keep logs of these sort of things so that it can learn from it. All right. So again, embeddings and vectors. We have, so an embedding, and I'm giving you some terminology because you have to have these in order to talk about these things. So an embedding is how we turn text into numbers, because again, computers don't understand, everything has to be a number for a computer. Even if you give it text, it's turning it into digital information. Then we have, and each embedding is a long list of numbers that is a vector that represents its meaning, okay? And then similar meaning vectors are grouped together, and that's how all of this is working. So an example is Iron Man armor might be this, and Tony Stark suit might be that. You notice they're very close in numerical values. And both land near each other when you do a map of these sorts of things. And that's how these large language models are working, and that's how we generate these RAG databases, these vector databases on the back end. Same sort of thing. We give it information that it already understands how to process, and it's a lot faster, it's a lot more natural when you want to speak to it. Okay? It's just a map, again, that lets us find the neighbors. And we can use these backends to search, query, and I actually have, here's the quick flow. So the user talks, it embeds something, and then it talks to the vector database and search, it retrieves the chunks, it gives it an augmented prompt back to the LLM, which produces the answer. Okay? Again, it is basically using that RAG database, that vector database, as an extension of what it was trained on. But it's obviously not going to be as fast as what it was trained on, because it's having to actually run queries to find this information. All right. So something I wanted to talk about real quick that is very interesting to me is, again, how do we make a Jarvis that, again, understands what I had for breakfast last Tuesday, or remembers that yesterday we were talking about a coding problem I was working on, and I want to continue that because I stopped working on it, all right? This is what some people are working on. I think all of probably the large companies are working on it because they want you to go to OpenAI and they want you to be able to talk about it and all stuff. And you'll notice OpenAI has some sense of memory now. You can say remember that, or every now and then you'll say something important and it realizes it's important and it will save that all, right? But that's a very targeted way of doing it. That's saying remember this, or if you see something important, remember that. But we as humans have a memory experience. We know how memories are formed, right? Short-term to long-term memory. right? You guys are going to remember a lot about what happened in this panel, at least I hope. At least for the the remainder of the day, you'll remember coming, you'll remember most of the stuff I talked about, right? But then you'll go to bed tonight. Tomorrow you'll start a whole new set of experiences, right? It's generally understood that those are what you experience today will be converted from a short-term to a long-term memory. What if our AIs and LLMs did the same thing, right? What if we talked to it and it used this human experience of memory to do something very similar? And we carve off the conversation history, keeping the memory of our large language model, the context window that we talked about earlier, keep it short so that the AI stays smart, right? And then carve that off into some of these backends. So we save all the facts in one place. So it looks at the conversation history. What were some facts that were important? I told it that I had a meeting tomorrow at 3 a.m. That's a fact. I wanted to know that. I wanted to keep that information, right? But then what if I just want to summarize anything that's not a fact? Because that's what we do, right? We remember we went to that panel last year, right? But we may not remember a lot from it, but it's an experience. It's something that if I ask it, did I go to a panel last year on such and such, it can go, yes, you did. I remember you went there. It was this day because it saved a fact associated with it. But it's not going to remember verbatim what you learned at that panel, right? Because if it did, you would take up a lot of storage. You would also give it a huge context for it to search through when it's trying to remember things. Same thing that works in our brain. We have to remember, while computers are vast and powerful and you have a supercomputer on a table these days, it still takes time to search through databases. It still takes time to search through knowledge bases. And so if you're going to make that too big, like I want it to remember every fact of everything I've ever done, that there's a penalty for that level of information. So we can use an LLM even to pick apart this information, right? We're already running an LLM. We already have access to an LLM, and we can feed that back into a side channel and have it pick out the facts, have it summarize what was discussed, right? And we can do this during the times that our large language model wasn't doing anything. So I stopped talking. It's resting. It's not doing anything, just like we sleep, right? So that conversation's over because I stopped talking, right? So now it will go and it will train itself. It will shorten its context, but it'll remember a little bit about what we just discussed, as opposed to if what I would have to do today on my model, which is completely cut off the conversation. Say we stop talking, start over because I probably hit my context window, or I probably already talked too long and you're getting done. All right, so there are already similar tools that do this, but not in whole. This is something I plan on working on in the future. There are other people working on it. I've already talked to a few AI engineers that are already working on this kind of thing, but I wanted to bring it up into this panel because this is the kind of information you obviously wanted to hear about in terms of how do we build a Jarvis-like experience. Again, there are tools, there's LangChain, there's MemGPT. They don't all work like this way, or they're parts of this, but they're not the whole system, okay? So let's talk about the practical application. This is the last part of the panel, and this was the part, like I said, I went into super maker mode because I didn't have a solution for this last piece I wanted. And so I developed, let's talk about the problem. Sorry, I'm getting ahead of myself. How do I take my AI with me? How do I take the AI that I'm running here? Or these days you guys have, we all have access to OLLAMA is the most common one. And I'll just throw that one out there. There's a lot of different inference models that are inference engines you can run out there. So I'm just pointing that out as the most common that I hear about. And so maybe you're just running it on your home computer and you know enough about IT to open that up to the internet to where you can query it from outside your home, okay? But you can run your own model, you can run your own AI. This DAWN process that I've built here, it is open source, it is C, it will run on almost anything. It particularly runs well on Linux because that's what I'm running it on. But it'll go with you. All right, the solution. Again, connect to your own system wherever you are. I can be out and about. And then think about carrying around, you have Siri, you have Google, but we know most of these things are not AI still. Most of these things are still acting just as a small assistant. They have a limited use set, but what if it was tied to your system? What if it was tied to your home? What if it was tied to your home automation setup? And let's not forget that the point of a lot of this is so that it's private. Everything you run in your home is your data, it is your information. You're not giving it to Google, you're not giving it to Apple, you're not giving it to Amazon. This is all local to you. And I'm a big fan of running local software so that you're keeping your information private. All right. But first you need your own system, so you got to set up a server. You got to give that server access to an LLM. And again, you can use LLM backends. All of them have their privacy models. Read your privacy statements by your large language model provider if you want to access someone else's service because you want a 128 billion, parameter model as opposed to a 4 billion parameter model, right? Or you can do what I said, you can run one on your local system, right? We're about to have access to computers that for just a few $1,000s that have 128 gigs of memory and will run on your desktop, right? And these are specifically designed for AI. And there's one coming out by NVIDIA, I forgot the name of it. The DGX. Right, yeah, and it's like $3,000, $3,500, which is still expensive, but that sits in your home, that's a private thing, and will run most of the large language models that are out there. That's 128 gigs of memory that it has access to. And again, our goals here, low power if we're going to carry it around, low bandwidth because you don't know what kind of networking environment you're going to be in, minimal dependencies. One thing I wanted to design with this system was I didn't want you to have Android or Linux or Windows or whatever. You had to have a bunch of libraries that may or may not work on every platform. So I wanted to minimize the dependencies on this. And so I developed a new protocol. Because, that's what we do. We develop new protocols called the DAWN Audio Protocol. Digital Assistant for Wearable Neural Networks, if you want to know what DAWN stands for. By the way, I just changed that last word because the other word didn't make any sense. All right. All right, so this is what I built. All right, here is the Fritzing diagram if you want to build one yourself. All of this will be published. Obviously, I've worked like a madman over the past week, so it's not published. And I wanted you guys to also have first access to it because you're at this panel. So all of this, if you want to take a picture, you can have it right now. All of this will be available online. I will publish all the source code. Again, I have a lot of cleanup to do. And so this runs right now. The only thing in this box is an ESP32 with the display. This is an Adafruit Feather display. It has a microphone hooked up to it and it has a speaker hooked up to it. That is it. And some LEDs because LEDs are cool. No functional requirement other than I had designed a box and the box wasn't very pretty and I asked AI to make it prettier and it has lights. And I went, yes, it needs lights. So thanks to AI gets its lights. All right, so this is it. It is on. I can show it to you, but it looks exactly like this on the inside, so I'm not going to take it apart right this minute. I will take it apart as I'm leaving because I got to unplug the battery. This thing will last hours on this battery. It is sipping juice while it is just sitting here powering the display and the Wi-Fi. This has built-in Wi-Fi. It is talking Wi-Fi directly to this. I haven't tested it yet, so this is a live demo. I tested it at home before I left, but I haven't tested it here because you got to see how it's running. I do need to run this. Now, right now, it still has that last Klingon personality because I haven't recoded this. So it is going to be our Klingon personality. But let's talk through this real quick. Again, it's very easy, very low dependencies. This C source is right now Arduino, but since it's an open protocol, since it can be written...
Sir, setting to AI to Cloud LLM.
Keep in mind, I have a low sensitivity put on this microphone right now, which is why I keep interrupting it. This AI is completely interruptible. You can interrupt her mid-sentence. If you don't say her name, though, she will continue talking right where she left off. And if she hears a wake word, she stops what she's saying and then starts over with what you've asked her to do. So that's why she stops talking like that. She hears me speaking. It's part of the design, really. Okay, so, so how does it work? Again, this is the ESP32 client. Very simple, just running that little board. You press the button, it records an audio as a WAV file. Again, no dependencies. You don't even have to have a compression algorithm on this WAV file. It makes it a little bit slower, but again, I went no dependencies on this. It transmits the audio to the server, DAWN. Speech to text converts what I just sent, because I sent it the audio. I didn't make the client do the audio processing. It just sends it over. Sends text to the LLM. LLM outputs a response. The response is then converted to audio, another wave. And then it transmits that back to the client. And the client then plays back the response. All right, that's it. And again, this is the same way that most of your audio clients at home work. This is the same way that your Google Home Assistant works. They are doing the same thing. They are doing all of the processing in the cloud and not making it. I think they may have moved a little bit of the intelligence to the edge. I don't have their software stacks, obviously, but this is the way the early ones worked. They waited on a wake word, they recorded your audio when they heard a wake word, and then it sent it up. So this isn't new technology. This has been around for about a decade or so. You see, saves power by not turning on the LEDs until I talk, and then the LEDs are actually color-coded to tell it so that I can simply look at it and tell what it's doing. Okay, Friday, are you there? So you see, that's all it was. And so now I have the same thing that I had on the computer, I have in my pocket. And again, it's Wi-Fi, so it can go anywhere there's a Wi-Fi network that I have it paired to. Right? I can include all that information in the source code. I can also take this same little Wi-Fi modem, the same little embedded modem that I have on here. I can connect this to that and have it everywhere. Right? So the idea is it can run on anything. Again, since it's a simple protocol, since I didn't overcomplicate the tech side of it and put all these dependencies on it, you could write a mobile app to work right now, and it could run on your cell phone. And it would be able to talk, because it's just uploading WAV files and receiving WAV files. Yeah, there's a lot to be done to this. If I wanted to productize it more, there's a lot to be done to it to make it more secure. But again, the idea was just a working demo and a proof of concept, and that's what I was going for here. Again, the colors, when you're playing it, it does have some nice colors. Green means that it's playing back, and then it goes back to this color cycle load. Again, the idea was if I'm holding it, I don't want to have a screen even. The screen is here for debugging, but the screen is not necessary for the operation. Switch back. All right, is that it? And that's it. I covered everything. I got done on time. So if you want to know how to, we're going to go through questions. I did leave 10 minutes-ish for questions. If you want to know where to find me, that's the link to the YouTube channels. The primary one is on the left. The secondary one is in the center. That's where I post like super tiny stuff that maybe the primary channel doesn't care about. Although I care less about that these days. So. And then there's a link tree for all of my other socials. But like I said, Kersey Fabs on everything. So if you want to find me on any socials, I'm not active on every social, but I do have accounts on all of them. I'm primarily active on YouTube and Instagram. If you want to keep up with my projects, Instagram is the best place to do so. And there's my DragonCon schedule. I have another panel at 5:30, which is a panel. I'll be there with a group of people talking about why we make. That's next door. And then join me back here Sunday for Hack Your Sci-Fi Armor, which will be in, again, it'll be next door. And that's where I will be discussing everything that I've done on my Iron Man armor up until this point. So if you want to join me, that's at 10 a.m. on Sunday, which is way too early for me. So I'm sure that'll be good.
Kersey Fabs is where we'll see the documentation when you get it online.
Yep. And yeah, and I have it's not up here, but if you go to theoasisproject.net, That's where I post most of the documentation surrounding the code base. All right, but you'll find that. You'll find that in a lot of other ways. Yeah, hands for questions.
What if someone can't really talk and they have like a speech problem, but they like have like buttons and have the computer try to guess when they're trying to communicate with them?
I mean, sure. So you could do that in any number of ways. You could have just a text interface. LLMs understand text natively, so you could just type what you wanted to do and what you want to do. You can even do what you do with. I've seen ways of like how like you communicate with animals and they learn words, and so you could like do a word board or something to where you could do words and just send those audio samples.
This would be for someone who has like a mobility problem, they should have to move. They're just looking for something to like interact with, kind of like that.
Yeah, I mean, so to interact with an LLM specifically.
Yeah.
Yeah, so yeah, I mean, you could have it put together sentences or other things as well. But if you were going to do that, like from it, there's no reason that you would want to communicate with the LLM at that point using audio. You could just go straight to text, skip the text to speech part, and even potentially have a large language model try to interpret what the person wants and make complete sentences or try to make a better interactive experience.
So maybe as an editor then.
Yeah. What else? Yeah.
For the agentic stuff, like what you showed in the beginning where you're turning on and off parts of the interface, how do you get the freewheeling output of the LLM to line up with commands?
One more time.
So like in the beginning when you were having it say turn on this part of the interface or turn off that part of the interface, is the LLM output like same thing enough?
Oh yeah. So what I do when I'm doing it, I'm doing something they tell me not to do, and I'm okay with that. And what I'm working on with my large language models is I want to give it information. Like, I want to give it a format. So I say I want JSON back. And if you're not familiar with JSON, JSON is organized text so that the computer can process it. And so I will give part of my prompt. You can't see it here because it's auto-generated. Part of my prompt is, here is my JSON. Here's my JSON model. Here's what you can tell me to do, right? And I tell the large language model, send me back JSON if I ask for a command. Okay. Again, they want you to do more of these function backends where you're giving the function on the backend. But that limits me to AI models or LLMs that have functional backends that can call functions, right? But this, I want to open it up to all large language models. And so one of the things I'm going to be doing soon is custom training models, tweaking models, not from the ground up, but where you can modify existing models to understand JSON better, to understand what I'm trying to get it to do better. And again, so when it's calling back to me to turn on the display elements or whatever, it's just sending JSON. I intercept those with my command interpreter, and then it sends it where it's supposed to go. Other questions? You got one up here?
Is your source code on GitHub?
Yes, all my source code is on GitHub. If you look at the OASIS project on GitHub, there is an organization, everything is under there. I think there is a beta version of this that I wouldn't recommend running, already sitting on a branch.
Did you try to do an existing IoT device like Alexa, or just wanted to jump right in?
Just wanted to jump right in. This was easier than hacking something new for me. All right, I'm very familiar with ESP32. I've done a lot of projects with it. I actually use it in my day job as well. So this was an easy hack for me. So, and again, I'm going to be publishing the markdown and everything for the audio protocol if people want to implement something there. It needs work. This audio protocol is version 05 of the protocol as I would do it, but it is functional.
If you release it, it doesn't need work, you release it.
Yeah, right. Yes.
Do you build your own training data, or do you pull up from the database?
So I'm using all open models. These models are available on Hugging Face. You can go to Hugging Face and download all these models. Like right now, I'm using either Gemma from Google or I'm using Quinn, which is I think by Alibaba, but it's completely open source. Quinn, or QWEN, or Gemma. and MA. Those are my two favorites, and I test with a lot of models. But again, they have to fit on here at about 4 gigs of RAM. So these aren't big models, these are portable models. These are pre-built, but like what I want to do is to tweak these models. You can actually take these models and you can add training to them. And you can modify the data that they already have. And that's what I'm going to be learning next. I don't know how to do that today, but hopefully within the next few weeks. Again, that has to do with taking a model, find a model that does the closest to what you want it to do, and then tweak it. No, I don't know, like you'd have to have a very special use case where you would want to train a model from scratch, other than just to learn how it works, just because you want to become an AI engineer. Yeah.
One, what is the difference between the LLM speech recognition and phone standard speech recognition? And two, what is the different levels of an AI, and how does it, the different sizes for servers, how do they operate?
So that's a complicated, so the first part of your question about like the difference between my speech to text and your phone speech to text, they're just running different models. And again, I don't, yeah, it's a model thing. Speech to text is a very small, specific machine learning model. It's not an LLM, it's just machine learning. It's been trained on human speech. If you remember 10 years ago, 20 years ago, it was really crappy because, you know, it had very small, you may even have had to train it on your voice. There weren't generic models like there are today. And so that's a important distinction that these are not LLMs. They're just small little models that are designed for certain human speech. And then the other one, how are these models layered? It depends on the model. So Google has some new, there's a bunch of technologies actually. Google has a new model that the small ones are embedded in the big ones. And so if you want a smaller one, it's actually a subset of the big ones. It's a whole new technology they developed. I think it's in their Gemma 3N that they developed for mobile devices. I forgot what they call that technology, but it's a layered model. Otherwise, they could be completely trained on different subsets. So whoever's training the model will go, this is what goes in a 4 billion model. Okay, now we're going to increase that subset of that knowledge. But if you retrain, as opposed to what I told you about that Google model, right? If you retrain, every model is then going to rebuild those connections. So the large ones may have a different set of connections than the small ones. And so you can't guarantee that just because I had a 4 billion and it did this, and then I chose the same family with just more parameters, that it will act similarly. They may not.
Would a small model that you run on the little video thing run as well as the larger model?
It will run faster, usually, than the larger models, because it, again, you know how I was saying, like, your large data sets take time to search? Yeah. Same thing with the large model. You need faster hardware, you need more RAM, you need faster RAM. All of that plays into how well the models run. So typically a small model will run better than a big model. Plus, you can do something called quantization, and quantization can take large models and make them smaller. And all you're doing there is you're taking precision and lessening precision. So it's taking the same model, but turning floats, which are decimal values, into integers. So you're creating less, there's less information there, or less linking, or less specificity. But you can make a model a lot faster. Plus, you can quantize for your hardware. So say your graphics processor natively understands integers better than it does floats. Then you could actually make it faster for your hardware at the sake of maybe accuracy. Yes.
It sounds like if you're compressing the information to pass it to the large language model in the next inquiry. Like the information about, well, how did you have your toast yesterday, right? After 5 years of interacting with this, that would still be a lot of information to pass. So is there sort of a threshold where you're going to have to update the large language model?
So I think what you would do, I mean, the way I would personally tackle this is the way that I think probably memory, I would again go back to our own memory. Do you phase out information? Or do you even take periods of time and summarize those periods of time to pick out the important things, right? So you could do the same thing that what I was talking about from short term to long term. You could do the same thing from long term to longer term, to where it picks out the important parts, but not. And keep in mind, something like summarizing large data sets, like into just even sentences, is way more consuming than words. Like, so facts, again, would be easier to have long-term than whole ideas. All right, that's it. Thank you all for sticking around.